Hello everyone! In part 25 of our roguelike tutorial series, we're going to be creating a level select screen based on the one in Vampire Survivors, as well as implement level buffs like bonuses to add variety and uniqueness to your levels. Before we continue, ensure that you've gone through part 24 where we made our character select screen first, as we'll be building on the UI and scripts that we've created from there. We'll first create the level select UI such as the select buttons, the level stat display, and a level entry template that can automatically be set up with level information for each map in our project. Then, we'll move on to the scripts that will give our level select functionality and create a class to store level data that we can easily configure to set up our level entries. Without further ado, let's get started. To start off, let's first mark our SceneController class as obsolete. To do this, head over to our scripts folder and double-click the SceneController script over here to open it up in Visual Studio. We'll just need to add in a line of code to mark this script as obsolete. Basically, the message that we set in the brackets will pop up in the console window to just serve as a reminder to replace the script once we're ready. Take note that obsoleting a script does not stop it from running, so our SceneController can still be used to load scenes while we're working on our newer script. Once we're done with that, we can start working on our level select UI. You'll notice that in the original Vampire Survivors game, the character select UI looks really similar to the level selects. They both use scroll views with icons and have a stats display showing information on the side. So, what we can do is just duplicate the character select screen we have and modify some UI to get it to look right. We'll just need to go into our scenes folder over here, select the character select scene, and after that we can press Ctrl D on our keyboard to duplicate it. Then we can right click it and rename it to level select, and then we'll just double click it over here to open it up. The first UI element that we'll create will be a back button to take us back to our character select scene. Let's head over and expand our canvas over here, and then we'll select the character select button. Then we'll press Ctrl D on our keyboard to duplicate it, and then we'll rename it to back button. After that, we'll set its direct transform anchors to the following values so that it will be positioned to the bottom left corner of the screen. After that, we can change the background color of the button to red, and we'll also make its text show that it takes the player back to the character select screen. Next up, we'll head back to our character select button and rename it to level select button instead. And then we'll also change its text to show that it selects a level. After we're done with those buttons, we can work on setting up the level select scroll view. We'll start by renaming our character select background over here to level select background. Then we can open it up and delete the description box since we no longer need it in this scene. Now that we've got a bit more space below, we can head over to our scroll view's red transform over here and set its top value to 75, while we set its bottom value to 20. We're leaving some space above since we'll create a stage selection header in our next step. Let's right click our level select background over here, go over to UI, and then create a new text mesh pro game object. We'll name it to level selection text, and we'll set its anchors accordingly. Then we'll change its alignment to the center, give it some bolding, and we'll make the text say something like stage selection, just like in the original game. After that, we'll go back to our scroll view, expand it a bit, and select its content game object. Then we'll remove its grid layout group and replace it with a vertical layout group component. What a vertical layout group will do is arrange its child game objects on top of each other, which is what we want since we'll have one level icon per row. We'll also set the spacing over here to 10 to leave a gap between each level icon. For the final edit to our scroll view, let's head over to its scrollbar vertical game object over here, and we'll change its color to yellow by modifying its scrollbar component down here. You can use the following hex codes on the screen to use as the respective colors. Now that we've set up the scroll view, we can move on to creating a level entry template. Just like with our character icons, we'll use an editor script later on to automatically generate the level entries filled in for us. Let's go back to our content game object, expand it, and delete all of the character icons that were carried over. Next, you'll want to right-click the content and create a new UI image to serve as the main template game object, and you'll rename this to level entry template. We'll set the width to 560 and we'll set the height to 140. You can also change the background of the level entry template to a translucent grayish color. Next up, you'll want to add in a toggle component to the level entry template, and you can also change its selected color over here to yellow to make the selected level more clearer. Now, we can go on to creating the UI game objects that will make up our template. They are the level name, the level number, the level image, and the level description. Just like with the character icons in the last part, you'll need to name the game objects exactly as how we'll be naming them. For example, if you spell level name with a capital L and N and a space in the middle, you should name it exactly like that as well. This is because the script that we will create to assign the level info to the template will use the game objects names to determine which piece of info goes where. Let's start off by creating the level image by right-clicking on the template in the hierarchy and selecting UI and then image. Then we'll name it level image with a capital L and I, and we'll set the rect transform to the following values. After that, we'll right-click the level image and create a new UI image called name folder. We'll set the rect transform to the following values to position it to the top of the level image. We'll also change its background color to give it some more contrast against the level image as well. Then, we will right-click on the level image again and create a new UI image, this time called frame. And then we'll open up the anchor presets menu in its rect transform. And while holding down the Alt key, we're going to select both the horizontal and vertical stretching in the corner over here. Next up, we'll head over to its image. We'll change its source image to a suitable frame sprite in our UI sprite sheet. And then we'll set the pixels per unit multiplier down here to 2 to make the outline thinner. Once we're done with the frame, we'll head back to our name folder, right-click it, and create a new UI text mesh pro. We'll call this level name, and we'll open up its anchor presets menu, and while holding down the Alt key, make it stretch both horizontally and vertically. After that, we'll set its text mesh pro component to the following values. Next up, we'll right-click on the level image and create a new UI text mesh pro that we'll call level number, and we'll set the rect transform to the following values. Then we'll customize its text mesh pro component accordingly. For the last template GameObject, we'll right-click on the level entry template and create a new UI text mesh pro, and we're gonna call this level description, and we'll set its rect transform to the following values. We'll also modify its text mesh pro component accordingly. And with that, we're done with our level entry template. It's a good idea to test out how the UI will display by adding in placeholder text and images to check if they're showing up properly. For the level image, you can head over into one of your levels, take a screenshot, and resize it to a 16:9 aspect ratio to use as a placeholder image. And if you'd like, you can head over to the Vampire Survivors Wiki to get placeholder text to use for your level name, number, and description. The final piece of UI we'll be working on will be the stats display. Well, let's start off by renaming the main UIStatDisplay over here to UILevelInfoDisplay. Since the level stats will contain less values, we'll modify its rect transform to take up less space like so. After that, we'll expand the level info display, select its stat name's GameObject, and modify the rect transform to take up less space as well. We'll also configure its text mesh pro component to ensure that the text displays properly. We'll do the same for the stat values as well, starting off with the rect transform over here, which we'll set to the following values. And modify the text mesh pro component to align with the stat names. Then, we will right-click on the UI level info display and create a new UI text mesh pro that we'll call extra stage info. Ensure that it's the third child of the UI level info display from the top, as we'll be using a script later on to assign the different stats based on their child index. We'll then set its rect transform to the following values to position it to the bottom of the display. Finally, we'll modify its text mesh pro component to make it fit within the text box. And with that, we're done with our basic level select UI. We're now going to create the scripts that will get our level select running, and the first few scripts that we'll create will handle our level stats. To begin, we're going to head over to our scripts UI folder and create a new C# script over here called UIPropertyDisplay. And we'll open it up in Visual Studio right here. So, what this UI property display is basically an abstract class that contains the named functions that are used to display our stats. To explain what an abstract class is, it's a class that cannot be attached to a game object as a component, and therefore must be inherited from another script instead. Abstract classes allow you to define virtual functions like this process name and process value down here, that provide a base function that can be overridden in the inherited script, as well as abstract functions like this getWordObject function down here, that are functions without any body that must be implemented in the classes that inherit from it. This will be useful for our stat display scripts, as they're all used to process and display info, except that they'll take in different inputs like character data or player stats. Hence, we can just store the basic processing and display functions in this abstract script, inherit them, and modify them slightly to take in different data types instead of creating new separate functions. Going back to the script, we've got a few variables over here. Update in editor toggles whether the stat display updates while we're in the Unity editor. Property names and property values are the TextMesh Pro UIs that will contain the UI text of the stat names and stat values respectively, and dash is just a dash character that represents any values that are equal to 0. Moving down onto the functions, the onEnable and onDrawGizmo selected are used to update the stat fields whenever the stat display is set active. GetWordObject is an abstract function, which is why it's empty, that must be implemented in the inherited scripts. It will be overridden with code that will be used to read the object we want to get the stats from, and we've made it abstract since we'll modify it to take in different stat types such as character data, player stats, or level data that we'll use later on to store the level's info. The next function is fieldShown, will be used to determine whether a stat field gets processed and shown on the UI displays or not, which is useful when you want to prevent certain stat attributes from displaying. After that, we've got processName and processValue down here. And what they're used for is they basically handle stat fields using their stat names and values respectively and process them according to certain rules. Like if the value is a float like 0.5, it will display its final value as a percentage, which would be 50%. Then we've got get properties over here. And this is basically used to populate and properly display the stat name and stat value text boxes after processing the stats. After that, we've got another abstract method down here, update fields. And it's basically used to get a reference to the text boxes to update and populate them with data from the red stat object. It's abstract since we'll have different ways of implementing how the stats of different data types populate the text boxes. Finally, we've got a static function, prettifyNames, that is used to display the stat names in their text box properly by adding spaces and U lines. After creating our UI property display, we'll head back to our scripts UI folder and open up the UIStatDisplay script to make some modifications. We've mainly just removed functions that already exist in the inherited UIPropertyDisplay script, as well as implemented the abstract functions with some body text. Over here, we've made getWordObject read from either a character data or player stats, and if you remember from our previous part on the character select, it will take in a character data provided by the character select screen, while in the game scene it will take in a player stats object instead. Moving down here to the update fields function, it just gets the current character stats and processes it accordingly using getProperties, and then it gets a reference to the stat text boxes to update, and finally it updates the stat names and values with the processed text. After we've modified the UIStatDisplay, you'll notice that you'll get an error in the console for our UI character selector as it uses a function in our StatDisplay script that we renamed. You'll need to head over to our scripts UI folder again and open up the UI character selector, and then we'll head down to the select function to rename the function over here to update fields instead. Once you save it, the error should be gone. Once we're done with that, we'll create a new script in our scripts UI folder that will handle our level stats. We'll call this UISceneDataDisplay, and we'll open it up in Visual Studio. Now on first glance, you'll notice that we're missing a UILevelSelector class, but not to worry as we will be creating it later. This SceneDataDisplay script functions similarly to our UIStatDisplay, except instead of taking in character data or player stats, it will take in level stats in the form of scene data instead. However, we'll be overriding more functions since we'll be processing the data much differently. First off, we've just made getReadObject read from SceneDataObjects instead if one is provided. If not, it will read from a new empty scene data. Up next, the update field function down here just gets a reference to the stat text boxes to update, and then it extracts the user and enemy stat modifiers that will be used to represent the level buffs and processes them accordingly. Finally, it updates the stat names and stat values with the processed text. Finally, we've modified the isFieldShown function down here to only display certain stat attributes that we'll be getting from character data and enemy data, such as the greed and growth stats, as they'll be used to show the levels buffs such as its gold bonus and XP bonus. If you'd like them to display other stat fields, you'll need to add them as cases into the switch statement. After we're done with the stat scripts, we'll create the main scripts that will get our level select screen running. Let's head over to our scripts UI folder and create a new C# script called UILevelSelector. And we'll open it up in Visual Studio. Now there's quite a bit to go through for our UI level selector, so let's start off by going through the variables so we know what each of them represent. First off, the stats UI variable stores the stat display that we'll be updating with the selected level stats. Next up, we've got a static int that stores the selected level's index, and another static variable called current level that stores a scene data, which is a class that contains a level's data such as its name and time limit. We've made it static so we can access and assign the level's values in the level's corresponding scene. We also store a list of all the scene data in-game, so you can both edit and easily select the chosen level. After that, we've got the toggle template that will hold the level entry template that we created earlier, and the following variables are just strings that specify the names of the template game objects to assign the different scene data variables like the level name and description to. We then have a global buffs variable that stores both player and enemy buffs, as certain level stats like the gold and XP bonus can be represented as buffs to the player stats like greed and growth respectively. Finally, we'll use a regular expression that will be used to automatically identify the selectable levels in the game based on their name. For a quick rundown on what the expression means, the exponent sign and dollar sign mark the start and end of the name format. The first set of brackets captures the level number, which must be in the format of level with a capital L, a space, and whatever characters that come after it like letters or numbers. Next up, there needs to be a dash in the middle, which can have a space before and after it. The second set of brackets capture the level name, which can be any amount of characters long. You can also leave it blank as well. Up next, we've created a public class down here called SceneData, and what SceneData does is it basically stores various data about a level, such as its corresponding scene, its name, level number, description, and icon that will be displayed on the level entry template, its player modifiers, which are the relevant player stats that the level influences like move speed, greed, luck, and growth, and then we've got the enemy modifiers, which can influence the level's enemies, such as their enemy health. We've also got a time limit, which is basically the maximum amount of time that a player can spend in a level, and the clock speed, which is the rate at which the level's timer counts up. Keep in mind that this only speeds up the stopwatch and not the level's timescale, so movement speed and attack speed will remain as per normal. Finally, we have extra notes that can be used to provide a short description of any special level mechanics, such as there being no drops or having an increased rate of enemy spawning. Moving on to the functions, we first got getAllMaps down here, which is a static function that is only meant to be called in the editor. We'll be creating an editor script later on that utilizes this function to fetch and store all the playable level scenes in a list based on both their file extension, which is .unity for scenes, and whether their name matches the map name format's expression. Next up, we have scene change over here that basically replaces the functionality of our scene controller script. It takes in a level to load and resets the timescale to 1. After that, we have load selected level, which is specifically used to load the selected level based on its index, as well as store the selected level scene data in the static current level variable so it can be accessed in the loaded level. It differs from scene change, as while scene change loads levels by name, load selected levels loads levels based on the level index, hence it's only meant to load playable maps. Next up, we have the select function over here, and this function will be called by the level entry toggles when they are clicked. This function assigns the currently selected level, updates the stat display with the current level stats, as well as create the global buff that will be applied to the level if any player or enemy buffs were assigned. Then we've got generate global buff data, and what this function does is it creates a scriptable object and loads it with the level's player modifier and enemy modifier stat values so that they can be added onto their base stats. Finally, we have isModifierEmpty, which checks if all the stat values in the modifier are 0, and if they are, disable the buff and prevent it from running. This will save us some processing power, as every buff, even ones where all the values are 0, must be checked with an update loop. Now that we're done with the script, we can head back to our Unity project, select our level select background under our canvas, and after that, replace the UI character selector with our UI level selector. We'll fill in the fields later on. After we've created the UI level selector, we'll need to modify a few scripts to implement some of its functionality. Let's start off by adding the global buffs to our player stats script, which can be found under our scripts player folder, so that we can apply the global buffs to our player. After that, we'll also head over to our enemy scripts folder and add a function to the enemy stats that applies the global buff to it as well. Finally, we'll be modifying the GameManager script under our scripts folder to retrieve the UI level selector's current level in order to assign the selected level's time limit and clock speed. For the new lines that we just implemented, we can access the current level straight from the UI level selector without needing a GameObject reference, since we've made the variable static. After that, we'll create one more editor script in our scripts UI editor folder called UILevelSelectorEditor, and we'll open it up in Visual Studio. Now to briefly go through what our UILevelSelectorEditor script does, is it gets a list of all the playable levels in our project and creates a new level entry template for each level with its level info assigned automatically. It's got a few functions. First up, we've got onInspected GUI, which just creates a button to toggle the editor script in the inspector and also provides a warning box if the template has not been assigned yet. Next up, we have populate levels list down here, and what this function does is it gets a list of all the playable levels in game, checks if their name matches the map name format as well, and if it does, it extracts the level name and level number to be displayed on the template. It also adds a scene data object initialized with the levels info to the levels list. After that, we've got create level select toggles, and what this function does is it just creates the template and assigns the relevant info to the different template game objects based on their names. Now that we're done writing these scripts, we can go back into our project and start assigning and setting up the different script components. Let's first head over to our UI level info display over here under our canvas and replace the UIStatDisplay with our UISceneDataDisplay. We will also need to make sure that its level selector is set to our UI level selector under our level select background. After that, let's first head over to our level select button and set up its button's onClick function. We'll drag in the level select background into its field, and for the function, we'll select the UI level selector's load selected level function to load the selected level when the button is clicked. After that, we'll select the back button and set up its onClick function as well by dragging in the level select background into its onClick field. After that, we'll set its function to be the UI level selector's scene change function, and for the name, we'll give it the name of our character select scene. Now we can delete our scene controller game object as it's no longer needed in our level select scene. We can now start setting up our UI level selector component, but first, let's rename our game scenes so that they fit the playable map name format properly. Just a reminder that the scene's name should start off with level with a capital L, a space, the level's number, then a dash that can have a space both in front and behind it, and then the level's name. The following list shows some examples of names that satisfy this level naming format criteria. In our current project, we've just got one playable map over here called Game that represents the first level in Vampire Survivors, the Mad Forest. So we'll just rename it to Level 1-Mad Forest to fit the level name format. After renaming our levels properly, we'll finish off by heading over to our level select background game object and configuring its UI level selector. First off, we'll drag the UI level info display into its stats UI field, and then we'll find our level entry template that we created. It should be under our level select background scroll view, viewport, content, and drag it into the toggle template field to assign it. Now we can click the Find and Populate Levels button down here to generate a level entry for the Mad Forest map in the levels list that we can configure. So let me just click it and open up the levels list, and there we go. Alright, so we've got a scene data element that has already been initialized with the level scene, its level name, and the level number, so we'll just need to fill in the other values like its description, its level icon which should be in a 16:9 aspect ratio, the player and enemy modifiers that will be added onto their base stats, the time limit and clock speed, as well as any extra level info that will be displayed on the level stats display. I'll just quickly head over to the Vampire Survivors wiki and copy over the values from the Mad Forest article to show you how the different stats can be assigned. Alright, so we've just added in the level's description and level icon. We've also increased the move speed by 10%. The time limit, which is 30 minutes, should be represented in seconds, so 1800 seconds. The clock speed will remain at 1, and there aren't any special level mechanics, so we can just leave the extra notes with dashes. We can then update the template with the new level data by going down here and clicking the Find and Populate Levels button again, like this. Now before we do any testing, let's head back into our character select scene, and let's open up our character select button, and make sure that the scene controller switches over to our level select scene instead of heading straight into the game. Once all that is done, let's enter play mode to test and see if everything's working as intended. So let's select the Mad Forest stage, and over here the UIStatDisplay updates with the level stat, which is what we want. Then we'll go back to our character select. Yup, looks the character select scene. We'll choose Antonio, which has the whip, and we'll select the character. Then we'll select the level again to see if the whip character gets chosen when we load in. Yup, everything works as intended. Let's just see if we're able to add in new levels into our levels list. Let's just duplicate the Mad Forest scene and rename one of them to level 2 Inlaid Library and the other to level 3 Berry Plant. So when we click the find and populate levels of our UI level selector, it should create level entries for the 2 new levels that we created. You can also rearrange the position in the stage selection UI by moving around the elements in the list. So let's just say I want to position Berry Plant as the 2nd position in the list. I just moved it up, and if I click the find and populate levels button again, it should update its position to be 2nd from the list. And let's just say if I delete both of these 2 levels, we can simply click the find and populate levels to remove the levels from the UI. Now before we end this video off, we'll be adding in a simple Reaper enemy that spawns when the levels timer has been reached that will serve as a way to end the game just like in the original Vampire Survivors. Let's first head over to OpenGameArt to download a new sprite sheet for the Reaper. We'll be providing the download link for it in the description as well. After downloading the zip file, you can unzip it and choose the sprite sheet that you'd like to use for the Reaper. For our project, we'll select the def.png sprite sheet since its Reaper looks the most similar to the original game, and we'll copy and paste it into our art assets folder. After that, we can head back into our Unity project, select the Reaper sprite sheet, and change some of its import settings. First off, we'll set the sprite mode from single to multiple, since this is a sprite sheet that contains multiple sprites, and then we'll set the pixels per unit to 20 to give the sprites an appropriate sizing in-game, and then we'll set the filter mode to point no filter to preserve the pixelated look of the sprites, and then we'll click apply to apply the changes. Once the changes have been applied, we can open it up in the sprite editor, expand the slice dropdown in the top left corner, and for its type, we can set it to slice using grid by cell size. We'll set the pixel size to 48 by 62, and then we'll set the Y padding to 2. After that, we can slice the sprite sheet, and we can click the apply button in the corner to apply the slicing. Next up, we'll be creating the enemy prefab for the Reaper, and since the Reaper acts like any other enemy where it moves towards the player, we can just duplicate one of our existing enemy prefabs and configure its stat values to be way more powerful. Let's head over to our prefabs enemies folder and duplicate the bat prefab by pressing Ctrl D. We'll then rename this newly created prefab to Reaper, and then we'll double click it to open it up in the prefab view. First off, let's replace its sprite renderer sprite with the first forward-facing Reaper sprite, which should be def_6. And then we'll head back to our art animations folder and create a new animator override controller that we'll call Reaper. After that, we'll duplicate the bat move animation clip using Ctrl D, and then we'll rename it to Reaper Move. And then we'll select the Reaper animator override controller and drop in the bat controller into its controller field. And then we'll override the bat move clip with the Reaper Move clip. Then we'll select the Reaper prefab again and replace its animator controller with the Reaper override controller. After that, we'll double click the Reaper move animation clip to open up the animation window, and then we'll just dock it to the top over here. And then we'll select the Reaper prefab so that we can configure its animation clip. We'll replace the bat animation sprites with our 3 forward-facing Reaper sprites by dragging them over. And then we'll copy and paste the second Reaper sprite after the third to make the animation loop seamlessly. After that, we'll click the 3 dots to the side of the timeline to show the sample rate, and we'll set the sample rate to 6 to paste the animation appropriately. Once we're done with the Reaper's animation, we'll resize its box collider to fit its sprite. So we'll set its X value over here to 2.3 and its Y value to 2.6. After that, we'll head down to its enemy stats script and we'll modify its base stats to make it have an unkillable or nearly unkillable amount of health. And then we'll make its move speed faster. And we'll give it a deadly amount of damage so that it kills the player instantly on contact and ends the game. Now that we're done with the Reaper's prefab, we'll head into our scripts folder and add a few new lines of code to our GameManager script to spawn the Reaper once the time limit has been reached. We've just added a few new lines to our stopwatch update function that trigger when the time limit has been reached. Firstly, the enemy spawner will be disabled to prevent other enemies or events from spawning, and any remaining enemies on the screen will be killed off. After that, we'll spawn the Reaper at a random point off camera near a random player. We've made it spawn near a random player for multiplayer implementations, but if you're on single player, the Reaper will just spawn off your screen. After we've added the script, we can head into our game scene, select the GameManager, and for its component, we can assign the Reaper prefab to the Reaper prefab field. Now, let's just check and see if our Reaper works in play mode. So first off, let me just head over to the level select background and change the time limit to something shorter like 5 so we don't need to wait that long to see the Reaper. And then we'll play the level. And then once the timer reaches 5 seconds, the Reaper should hopefully spawn off screen. Oh, there he is. And he is fast and he'll kill us in one hit, ending the game. Hopefully, with these new level select scripts, you'll be able to add more variety to your level mechanics, as well as easily create and modify your level information. Thanks for watching, and we'll see you in the next part.